Hello everyone and welcome to another video of the AWS database series. Here we discuss AWS cloud databases, their cool new features, and how you can actually implement them in your own environment. My name is Camilo Leon. I'm a solutions architect specializing in database technologies. And today we're going to be covering a series of customization techniques for RDS SQL Server to make sure that all your RDS SQL Server workloads are running in the most cost-efficient manner possible, but still maintaining optimal performance. So let's dive in. So the first, I want to just go quickly over what are the cost components of RDS and how you actually pay for RDS. And then a very high-level overview of what are the optimization strategies available. The reason why that is important is because depending on the feature you use or how you use the RDS, the cost can vary quite a lot. So here, for any workload, you basically, sorry. So here first we're comparing the traditional cost model versus an RDS cost model, and the fact that basically what been historically the case is that DBA has been tasked with sizing a database server, and they have to look ahead 3 years and make sure they have enough capacity and actually make sure it runs properly with the current and future needs of their business system. So that, because it was kind of hard to provision hardware and all that and adjust. And I never seen a DBA ever in history get in trouble for over provisioning a server. However, the opposite case, is quite different. So, but then as we move to the cloud, we started kind of like a move, a different approach in which we actually size things differently, and we actually are a little more aggressive in terms of how you provision your resources in terms of compute and storage, because it's a lot more flexible. The idea is to actually leverage and enjoy the elasticity of the cloud from a compute standpoint and a storage standpoint. So now, in terms of what the pricing model for RDS, how it works, is basically you pay for compute and storage, regardless of what features are enabled. So that there is an important decision, which is the sizing of that, how you're going to set up that instance class and what instance class to choose. We're going to talk a lot in more detail about that. And then storage, the options keep growing. It used to be just GP2, IO1, now we have GP2, GP3, IO1, and IO2. I think IO2 Block Express is already released, it's already in use, and you can actually leverage those volumes. And then depending on how you set up your backups, it might be free, included in your RDS, I think the first 7 days, or you pay extra, depending if you need a longer retention than that. Then for data transfer, in those deployments that involve more than one region, there's also some charges for data transfer. But then again, that's a balance we're going to discuss, because maybe, yes, there's an initial cost, but you do need that multi-region deployment for compliance reasons. So it's kind of like a balancing act. And then there's some features that do cost, like a multi-ADC feature. But depending, if it's enterprise, it's basically roughly 1.5 compared to single AC. If you're using a standard edition deployment, it's twice as much. We haven't been able to get that down yet. That's a working product service team. The idea is there to remove the licensing costs from the passive node. But that has been done for enterprise, but has not been implemented for standard yet. So you pay for the snapshots that you take manually, separately, cross-region snapshots. And if you enable the re-replica option, also you pay for that, whether it's in region or cross region. Now, these questions here are just a set of generic questions. The reason I put it here is because the idea behind this offering was this is kind of like a follow-up after the well-architected lens and the customization pillar. If you want to go deeper, you can use this artifact to actually just go deeper into the subject of customization. But then if you go to the well-architected lens, you're going to be confronted with these questions, which I think are interesting questions to actually in general think about before you get deeper into this, the subject of customization. Because one that's also, it's always a sore subject, but it has to be brought up, is the issue of data retention. I mean, you ask the business users or the people in the app side, they want to retain everything forever. But then you have to put the cost on top and see how you actually kind of negotiate, see you can find a better happy medium. Then all these things about licensing costs, I mean, there's things that people don't know about. They actually, since we're renting the license as part of the compute, when you turn off the instance, you're not paying for the licensing. So those are things to keep in mind. Also, when you also deploying replicas of things about, they don't have to be exactly the same as your primary server, because they're not serving the purpose of high availability. They're serving a different purpose. So depending what are the needs of those reporting users, they could be smaller, bigger. So now, in terms of example workloads, so what I did is we anonymized this example. There's a customer that had a number of RDS instances across 3 regions. Of course, the heaviest, the more higher density was in the US East 1. So each of these blue cylinders represent an RDS instance. And then there's a little less instances in the US West 2, and they'll have a few deployments in Europe too. There's also a list view for this. Usually the way this starts is they give you a list of RDS instances with some configuration data and some resource consumption metrics. And that's kind of like the starting point of the process. I didn't include the list view here yet, but then here in summary, what you're going to see here, this example, it was about $110,000 a month before we started. After we ended with optimization, we ended up at 63,000. So what we're going to do here, as we go through the section, we're going to see how we actually made it to that number gradually. Okay. So now, before we actually optimize, you definitely need first to know how much you're spending. So that's why the first point here is cost monitoring. So then for that, AWS has a lot of tools that can actually make it very easy for you to keep track of cost of your RDS spend. The first one is the cost and usage reports and the cost explorer, which we're going to talk about a little bit in more detail. AWS budgets, CloudWatch, and the Trusted Advisor also has a customization section that, surprisingly, it actually does have sometimes very good advice there. Elastic, I just added here for completeness sake, but it's actually not really a cost optimization tool. It's more like a re-architecting option, because the idea is if you put a cache in front of your server, you can definitely get by with a smaller RDS instance, therefore pay a lot less if it's a heavy on the read workload. So now, in terms of the first 2 tools to monitor, the first thing you need to do, which is important, is to tag your workload. So you want to tag what environment it belongs to, what is the business application that you're supporting with this instance. And then with the Cost Explorer, you can start looking and browsing right there to see which are the ones that contribute most of the cost in general. So it's usually a specific app that kind of aggregates all the consumption, or it depends on the environment, etc. Now, the cost usage report analysis is kind of like a tool that allows you to go deeper into when you have a bigger footprint that you want to analyze and run some more sophisticated queries. And actually, you can actually create a report that gets stored in S3, and then you can actually do with Athena and QuickSight some actually more deeper visualizations. Now, the other one that's very easy, that is a lot of bang for your buck, is that it's actually a free service. It's AWS budgets, and I think my recommendation in general here is that usually when people deploy RDS SQL Server, is the end of a whole sales cycle that have been doing estimates after estimates after estimates. But believe me, I know, I've been through a lot of those. So there's always some reference estimates of what is supposed to be the spend when they actually implement or migrate to RDS. So what I would do, what I'm trying to encourage all customers to do, is as soon as they actually start, to actually set up as your budget your original estimates to see how you're doing compared to what was originally envisioned in those pre-sales sessions. And then as you move over and below, you can set up some monitoring. You can get some email notifications or via SNS. So it's very, very convenient, very easy to use, and very useful, in my opinion. Now, Trusted Advisor is also there for free. It's actually running behind the scenes and providing recommendations. And one of the sections of Trusted Advisor is actually the customization. So that's something worthwhile. Take a look and see if there's anything that you have missed, that you haven't seen before. Now, going deeper into the first angle about, because the biggest portion of cost for RDS is the compute cost, because the compute includes not just the EC2 machine that's running your instance, but also the license for SQL Server that you're renting that's there. So it's just a big part of the cost in general. Really a lot more than storage, for example, depending in general for most setups. So in terms of compute, the things that to think about is that the first one is some people think it's a billing model because in general there's the perception that you want to go with a reserve instance immediately, and that might be true for production environments that are stable, steady state, etc. But then in non-production environments, on demand is actually a better way to go because you can actually turn them on and off as needed. Instead of be running 24/7, they can be running 12 by 5, and then you can save a lot of money. You're going to get into that later. So that's one thing. The other thing is to see the actual utilization of your resources, your compute resources. And now we have even better, as faster machines, more memory per core. So I think one of the most popular ones for me is the X2 AEDN. It has like 32 gigabytes per core, and it comes with local NVMe for 10 TB. So it's a really very highly performant machine at all sizes. So it's actually with a very basic configuration like X large, you can take on significant workloads. So then in general here is that usually in those on-premise environments, what you see is, very low utilization, under 50. I've seen people that actually when they see peaks of 80%, that's like a major alert, and there's a special meeting, they're worried about sizing. Yes?
Cost of the SQL Server license, is it based on the CPU or the memory?
It's based on the cores. It's paid per core, and that brings to a good point, which is actually the instance type. So, in general, you're only licensing per the number of vCPUs that you have in your instance. So that's why I favor instances like X2 AEDN, because you get 32 gigabytes of RAM per vCPU. So with the 2 vCPUs, you already have 64 gigs of RAM. So it's a pretty sizable machine. And from a license perspective, you're just paying for one license, one 2-pack that you're renting, either standard or enterprise. So very good point, and that's actually why, in general, I favor memory optimized instances as opposed to the standard ones, because at the end of the day, the difference in cost is marginal, and you get a lot more, in general, SQL, the more RAM you have, the better it goes. And also options, things like when people have blocking issues in their apps, you can select a few key tables that are in the middle of all the joins and make them in-memory tables, and that removes all the blocking problems altogether. So there are things like that kind of open up when you have a system that has a lot more RAM available. Now, so one of the first things before getting into the details of how to adjust and size the CPU and the RAM, the first thing, the easy win is that any non-production environment, I by default always when I'm sizing them, there's a tool called the TCO calculator, SQL Server TCO calculator that I use quite a bit for these estimations. In there, I actually assume that any non-prod environment is just running 12 by 5 as opposed to 24/7, and that's about almost 70% savings right there. Unless, they have a global team of developers, they're following the sun and whatnot. I mean, in those cases, you have to keep them running. But in most cases, that assumption works well, and it saves a ton of money without you having to do much. And then this is something it's just a cloud formation template you can download and deploy, and then you can easily set up your schedules. And it has a 5-minute granularity, so you can be very precise about how you start and stop these instances. So it's very useful, and very easy to implement. Now, coming to the subject of CPU, here's where I get a lot of pushback from customers, but I think I'm finally getting through the message. It's like, you should aim for higher average utilization. At the end of the day, in theory, putting aside performance and the fact that, workloads vary, if you have your CPU 100% of the time, that would be an ideal scenario. You're actually getting all the money it's worth in terms of compute power. But I understand that's not possible, but in general, if you want to go be above 50% in general, or more than 60 or 65% on average. And actually, the beauty of this here is that if you have instances in production, assuming you have multi-AC enabled, if you need to scale, scaling is just modifying the instances, just the downtime is just a failover that you can schedule in any maintenance window. So in general, I always encourage them to be a lot more aggressive about the CPU, and I always have a little story here that I actually lived a former life when I was at Microsoft. I mean, we had to migrate a workload from Oracle to SQL in a very tight window. So we had this group of this collection SAS packages, one per table, and there's a PowerShell orchestration solution there. And you could run in parallel. You can configure how many you could run at the same time. So you have to provision this ETL server, run the thing as fast as possible, hand it over to the people to verify, because it was a patient records, medical history, so there could be no mistakes. And the sweet spot was about 50 packages at the same time. So it was amazing when you actually run this thing. It was at 100% that server for about 2 hours. And then it tapered down until the finish. And there was no errors. You saw a lot of context switching, CX packet, a lot of CPU-related waste and all that, but no errors, though. And then at the end of the day, when you check, everything completed actually, successfully. There was no stability issues. There was no problem. They didn't have to repeat the migration. So actually, that became the pattern. And people start kind of getting more confident in that customer about, really using their servers. So that's when I'm not advocating for being at 100% of the time at all, but I'm just trying to kind of like loosen people up a little bit and kind of try a higher baseline. It works, and actually it's easy to fix, is the other thing. Now, when it comes to memory, it's kind of like the opposite. You have to be a lot more conservative, and you have to be careful, because if you start an OS server out of memory, you're for sure getting into trouble. There's no two questions about that. So in that case, yeah, it's definitely you do need, but the thing is here, the key theme here is that you want to make sure that you actually measure how much is actually being used versus allocated. So that's the only thing. There's some counters that actually let you see if there's any memory pressure, like memory grant spending and the page life expectancy. Not so much the value, but the trend. If it's not going down, if it's kind of stable, it means there's no pressure from a memory standpoint. So then here with memory, it's actually, you should be a lot more conservative. That's why I think the instance type is what can help you, because R5, R6, you get 8 gigabytes per vCPU. With X2 ADN, you get about 32 gigabytes per vCPU. So it depends on where you are. You use one instance class or the other. I usually revolve about those three classes. I never use the M's or the others, just R5, R6i, or X2 ADN. But here is a list view. I told you about the actual workload. So here what I did is when we looked at the consumption, or CPU consumption of this actual example, we identify a few servers, there are 5 highlighted there, that we can downsize to at least half. So we basically changed it to 2x large to x large in both sides. And I think on the next page, the next one, there was one more. But that just rendered some, modest savings at 8.9%. But it did help a little bit. So the idea is to see step by step how this can apply in your work. So here, by doing compute optimization, just downsizing these servers, we saved about 9% on our compute cost. Now, moving on to storage optimization. Here, the idea here is first is what kind of storage you should use. And in general, I'm thinking that since GP3 became available to me, GP2 became kind of obsolete, because at the same price you get basically the same volumes as GP3, and you can control how many IOPS you can actually provision if needed. So it's just a bit of general. The other thing that's exciting is IO2. It's already available, but it still has the same limit of 16 terabytes and 64,000 IOPS. But then I think Q2 is supposed to be releasing, 64 terabytes, via, dynamic auto scaling and up to 256,000 IOPS. So that'll be interesting because that used to be a problem in many cases that you have to go up in the instance class to kind of get the throughput and there was some limitations actually to meet certain SQL Server workloads. So in general, I mean, the idea is to have some leeway there for growth, but not so much. In general, in on-premise, I've seen like this, the allocation is just ridiculous, the amount of space they pre-allocate, and there's a very little use. The idea here is to actually leverage auto-scaling as much as you can. And then there's also the issue of the retention of the backups, to really pay attention that you just retain enough backups to meet your RPOs and not anything more. And the manual snapshots, to also keep in mind that you need to delete those or they will just stay there forever. An easy strategy is just to maybe set up some retention in your S3 bucket. Now, in terms of IOPS, I said, what you want to do is write and read IOPS, but then here you're looking for the peaks, the sustained peaks as your reference, and that's to see that's your reference, how much you really actually use, really need to sustain that workload. And then if it's IOPS are kind of low, and they totally below 16,000, and GP2 or GP3 are good options. You don't need provision IOPS. Another thing that you have to get into is always a kind of like an old subject, but it does help a lot, is that, it's some schema optimization, because I've seen more often than not is that the database schema people, there's a lot of iterations over the queries and whatnot, so they have a lot of duplicate indexes that they no longer use on using, and people tend to forget that that's a separate, B tree, it's more like a separate table that's being maintained there. It's not only, slowing down all the updates, it's also, occupying a lot of space. So it's a lot, I think it's worthwhile to actually look out for these unused duplicate indexes and remove them. And the other thing when I say with efficient indexes is that a lot of times you can consolidate many indexes into one. There's some property that's not everybody always uses, which is the included columns. So you can have the key plus a certain number of include columns. You have a covering index, and then that way can serve more than one purpose. So that's something to keep the eye out. And then data compression, which actually became a standard edition feature some time ago, is excellent because you can actually fit in a lot more data in less space, and that also reflects on your storage footprint. Backups has like a ripple effect, which is really important. And as I said before, the retention of your backups. Now, if we look at storage here in a sample, this angle didn't really produce any improvements because they only have provision IOPS for 2 servers, and I think they were right size. When you aggregate the read IOPS, the write IOPS, they're very close to 10,000. So actually, they're accurately sized. So there was no suggestions there to improve. Now here we're going to do addition optimization. So here's interesting because what happens is some people forget is that the features included by addition to SQL Server is a fluid thing, and it moves as the versions evolve. And the more we move forward in time, the more and more the enterprise features become standard. For example, partitioning used to be an enterprise-only feature, and now it's standard. Compression, the same thing. And, as even the TDE used to be an enterprise-only edition feature, the transparent data encryption, and that also is standard in SQL Server 2019. So here, in general, my approach is when I'm sizing and trying to get things to be as optimal as possible is to move people up as close as possible to 2019 and downgrade to standard. Because if you downgrade to standard, you get 4x less, it's in terms of cost per core, and it's just basically the same feature. So the only real reasons to actually use Enterprise Edition is the size of the machine, or that you need always on availability groups for read replicas. Yes.
So you need online index rebuilds.
Yes, but then on that point, that's about the only feature that's still out there that's relevant. Yes, and thank you for bringing that up. But That feature was a lot more important in the times of spindles, and they have these disks that were actually rotating. But right now, when you have these volumes that are based on solid-state drives with several layers of virtualization and caching, write and read caching, external fragmentation is no longer relevant. I actually tested it with several customers that they're struggling with their indexes and they can't run them, and I tell them, well, stop. Just don't reindex anymore and just let them be fragmented and just update the statistics often. And the result is that they get optimal performance and nothing really happens if you don't rebuild your indexes. So the only thing that remains relevant is the internal fragmentation, which is when you insert, update, delete, and all that. The B tree has all these nodes, they're kind of half full and not at the size, the fill factor you want them to be, so there's some bloating. So that's something you can do, but you can do it once a year or something. So then it doesn't have to be online. It could be in a maintenance window or something. But then that's the thing that I think I just in Argentina with a big online gaming company, they had that very issue. And my recommendation was stop. Don't re-index. And they were like so happy because they could even lower the IOPS in the storage. They were all happy, and the performance actually pretty good. But it's true that you don't have that. I mean, if you have a dynamic environment, you're still developing and you're creating new indexes to improve things, maybe you do need that. But if you have a stable system and you just rebuild that every week because it's the best practice, we keep hearing Kelly Delaney for 30 years, that is no longer the case. So I think that's something you can actually ignore, in my opinion. But you can test. I mean, I can always say you can just test, measure, fragment it, run the query, see the time, the number of logical reads, and then time it again after. And you will be surprised that in most cases, it's exactly the same. Because the solid-state drives are fragmented by design. So it's no longer relevant, external fragmentation. Now, in terms of size, the upper limit is 48 vCPUs, but actually it's supposed to be, according to the documentation, 128 gigabytes of RAM. But actually, I was able to verify that's relative. It only applies to the buffer pool. And also, it depends if you're using in-memory tables or not, how many users are connecting, some of the features you have enabled. So I actually verified this same customer in Argentina that they've been running on standard on a 12XL, R5D 12XL, and they'll be consuming all the 300 gigs of RAM without a problem on standard. So to me, that's a new bar. It's not 4XL, it's 12XL. And so then beyond that, you definitely do need enterprise, especially because of the RAM, because then you're going to be wasting a lot of memory if you have these big machines, especially the X2 ADNs, and you don't have the addition to actually make use of that.
Hey, Camilo.
Yes.
This is Jose. I wanted to share something that I saw. It is not very common, but even when we say about the 128 gigabytes of RAM for standard edition, that comes in with a grain of salt. And what I'm referring to is that 128 goes towards the caching, not necessarily to the total amount of memory within the server. Because yes. I have a couple of customers that are using standard, and the total amount of memory currently being used by the server, and that's because of all the number of connections and everything else that goes associated. The instance itself is consuming over 300 gigabytes of memory.
Yeah, that's. Thank you for sharing that. That's exactly what I've observed in some of my customers. So I'm glad to hear that my assumptions are confirmed. That's actually, that's why I'm thinking that the new bar is actually 12XL, which is closer to 300 gigs, 48 gigs of 48 vCPUs. Yes. Yep. Thank you.
That X2 type comes in very handy, so they don't have to pay for the additional licenses.
Exactly. That's exactly right. So then here, let's see how this applies to our sample workflow. So here, this table, I just want to highlight that you can see here in the table, this is 2019. Basically, everything is included in standard, maybe with the exception of, with the scale limits we just discussed here that Jose brought up. There's 48 and the RAM, which is actually a lot more. And maybe transparent data encryption is also a standard edition. There's only the online indexing, which I think is in the last page. Yeah, the one it's not a standard edition. So then here I have some links to previous versions of SQL and which ones are how they come by standard, enterprise, and all that for your reference. But in general, what I try to encourage my customers to do is move to 2019, keep the compatibility level to whatever you were, so you don't have to modify your apps, and then downgrade to standard. That's the practice. So when you do that here and you see the workload, I mean, these people, they were using enterprise for everything, for all these production servers. But then what I did, as you can see here in the graphic, I mean, these are using enterprise, all these R5, they're being downsized to standard in that column. And then by doing that, we actually saved 39.5% in cost just by doing that, keeping the sizes as they are and all the rest unchanged. So here, the key aspect, the angle of optimization that actually made the savings was that downgrade to standard. And there are things like that, like always on, for example, if you have older editions of version of SQL Server like 2016 or 2014, with standard and you only have mirroring, RDS provides the automation to make sure that all your user databases fail over together and fail back together, just like an always-on AG. So you can actually, by the fact of moving to RDS, you can actually stay in standard and have an experience which is equivalent to enterprise in the sense that it works like an availability group. Okay, moving on here, data transfer optimization. Here I'm going to go quickly over this because here there's always a balancing act, but it's important to be aware of it. We don't charge anything for inside to bring in inbound transfer, but outbound there is a charge. And then here in these multi-regional deployments, when you have a multi-tier solution and when you have different availability zones, as you can see the red arrows there, those are what the charges incurred when you're moving data between EC2 and RDS. But then again, I mean, you have to have this deployment over multiple ACs and you need the multiple tiers. So it's just something like more like an awareness of that. And then also remembering that when you're on RDS, all the transfer between availability zones for multi-AC is free of charge. Only if you replicate your backup to another region or you have a replica to another region, then you get a data transfer charge. So in general, it's just the recommendation is to review what are the consequences of what are the data transfer scenarios in your environment. And then understand if you really need to replicate those backups to another region or not, depending on what your requirements are in terms of, it depends on financial institutions, for example, require that. It's just something to be aware. But in many cases, I think the resiliency that you get in your solution by far overcomes, the potential data transfer costs. In the case of our workload, since they're all the instances in scope, they were just locally deployed and they were supporting local applications. There were no data transfer costs to analyze or basically optimize. So we didn't do any changes in terms of data transfer optimization. Now consolidation, which is the last angle here. Here there's several approaches. But here, that's again, the more density you have your instance, the better, right? Because these are expensive instances, but of course we have up to 200 databases we support per instance in the bigger instance classes. And so there's many ways you can actually consolidate. An easy one is the one with the cumulative purpose, so you can have a single dev instance, a QA, staging, and with that kind of metaphor, because you can turn on and off with the same schedule. It usually works out. The other one is that they're similar workloads in the sense that they're supporting the same application, so you can consolidate that way. That's another approach. It's very popular. The other one is by line of business, because usually they have the same HADR requirements, and it's kind of you are dealing with the same people, so it's kind of like it works in big organizations. It's actually very practical. I actually use that approach with several customers here in North America. And the last one is ideal, but it takes a lot more work, is to actually create a tiered database services platform Then you can actually have nodes, standardized nodes for silver, gold, and platinum, and with different specs and different HA capabilities. And then you can just use that with as chargebacks. So you can then just have like a system in which you can actually, depending on what the users needs, you can just give them a database in the appropriate tiered instance. But it takes a little more work to kind of implement that, but it's actually very effective once you get it up and running. But the other considerations here is when you're consolidating, we'll expect that the CPU is going to be higher. So you need to be aware of that when you look at the historical data. You need to aggregate the CPU utilization of the other instances and minding, what kind of the amount of vCPUs they all have, and kind of do the math and make sure you're not running yourself into trouble. I'm not too worried about the non-production environments because the way I see those and the way I size them is they should be just big enough to support functional testing. If you need any kind of load testing or performance testing, you should provision a transient environment that actually matches production, run your scenario, and then deprovision the environment. And those, you keep your non-production environments very lean and just on 12 by 5 to minimize potential costs. But then in production, though, when you're consolidating, you do have to do the math in terms of, what's the aggregated CPU consumption that's driven by all these databases hosted in these, say, 5 instances. The other thing is you have to do the math too with memory, but the memory can get tricky because that freeable memory counter from CloudWatch is not very accurate all the time. So you want to double check that. There's a process level, which is private bytes, to see how much memory SQL Server process using, or the buffer manager database pages, or total server memory. Just to make sure, double check and look at, again, historical data and make sure that you're actually moving to an instance that actually has enough memory. What I do here is usually when you're on R5 or M or these classes, when you move to the consolidated one, it's typically going to be like an X2 ADN that has a lot more RAM per core, so you can be definitely covered from a memory standpoint. And then with the IOPS, it's also you need to aggregate the IOPS and the throughput, make sure you get the right volumes. Maybe you have all these GP2 instances that end up consolidating to an IO2 volume. And then TempDB, I here again recommend any of those that end with a D for your target environment, like R5D, AM5D, or X2ADN, because they have this local NVMe storage, which is incredibly fast and is set up following Microsoft best practice across several data files. So actually increases performance, I've seen in many cases. Here's some additional links and references to actually think about how you strategies to consolidate. And now let's see how that works in our example workload. So here, the way you read that is that all the blanks on the right, they've been consolidated to the instance above. So basically, like these, this one here is consolidating all these other workloads up here. And these 2 go up to this one, these 3 go to this one. So that's why I just sorted it that way. So to see a potential consolidation scenario. So here, after doing this exercise, we ended up with a potential savings of 31% by doing consolidation as proposed here. Especially, you look at here, the non-production environments can be consolidated by purpose. And here the development ones are also being consolidated. So that's what I did. The first strategy, just consolidate development instances, QA, and staging into a single unified instances. By doing that, it was about 31% savings. What happened here is that the customer declined. They didn't want to implement this change because it did involve, maybe routing the apps to different, instances of small minor changes in connection series and stuff, but they just didn't want to implement that change. So at the end, when we see the final results, after applying basically the compute optimization changes we did, plus the additional optimizations we did, we actually ended up with 44.9% savings, which I think it ends with that 63,000 as opposed to 110 when we started. This is an actual offering that I deployed in North America. And it beat many like that. And actually, the addition one is one that a lot of people oversee. It's just rethinking. And that question is, do I really need Enterprise Edition? It's something you need to ask yourself, especially within the context of you're moving to RDS and you get all these automation, all these features, things like what I alluded to with database mirroring. So that's a key question. The other key question is, how much CPU do I really need? So the two key questions. And it's usually a lot less than what they have. As I said before, I've never seen a DBA get in trouble for over provisioning a server. I mean, really, I did that when I was in Microsoft. I mean, and you justify the documents, their capacity plans and projections and stuff. Oh, but if you fell short, oh boy, it was a very different story. So those things, those reflexes die hard. That's why I think we need to keep pushing that idea that run your servers hot, let them be on a higher baseline. It's okay. If it's not enough, you can easily switch. And that's the message I'm trying to push out there in the field. Thank you so much for taking the time and going through this video. I hope you found the content useful and that you'll be able to apply what you learned today in your own environments very soon. Enjoy the rest of your day, and as always, happy cloud computing from everyone here at AWS. Thank you. Bye.